Good morning, students. I welcome you for this today's session. In the last class, we discussed some numericals based on that work and energy. Today, we are going to see the new lesson that is called sound. I hope you can understand. After saw this video, just take your book and read it once. Okay, students, today we are going to see that the lesson sound. Okay, see, actually, think about that different objects which is present. When you look around, means even birds, human, factory, so all are some kind of sound is producing, right? They are producing some kind of sound. Even lot of musical instruments and even air, presence of air and a lot. So the objects which are present in that atmosphere, all the one are some aspect, it will create some sound. Am I right? Even we and you, everybody is producing some sound. Okay, so the question is, we already know that sound is a kind of energy, right? So sound is kind of energy. So sound is it's a kind of energy. In the previous class, we know about that energy, right? Energy is conserved, right? Conservation of energy. So the conservation of energy, which means what? Energy is constant. We cannot destroy or we cannot make the energy, but we have to transform the energy in one kind of form to another kind of form. So these are the things we studied. Am I right? Even in the last class we studied that mechanical energy, right? So what's mean mechanical energy? So the mechanical energy, it is nothing but the combination of that kinetic energy and potential energy, right? So kinetic energy and potential energy. So simply we called it as mechanical energy. Okay, we said sound is a kind of energy. So which can be perception or which can be hearing by using that ear, right? By using that ear, that organ, specific organ, we can hear that sound, right? So we can hear that kind of energy. So here, by sensation of hearing, that energy will be transformed, right? So we can hear, right? So for example, if the air is blowing, if the wind is what's called blowing at a maximum speed, so we can hear that sound. We can that energy will be transformed through that air, through that medium, and it will reach to the ear. Am I right? Okay. So sound is a kind of energy. So through the sensation of ear, we can hear, right? Okay. First one, how that sound is formed. Okay. So in this lesson, we are going to see that how that means propagation of sound. So how sound gets propagated. Okay. And whether the sound is travel without medium or not. Okay. Sound is traveling without medium or not. Is medium is necessary, otherwise, okay? So without medium or not. Okay. And then we will see that some basic properties about sound. So this is the today's class. Okay. So before that, I will say one thing. So without giving any energy, the sound will not produce. Am I right? For example, I am speaking. So that means I am giving certain energy, right? So that energy will be transformed into sound energy, right? So that means what is the thing is, so without energy, the sound is not possible, right? Without some kind of energy, the sound is not possible. Okay. Now Now you have to know that whenever we have to produce some kind of sound, there will be some sources needed. Okay, some sources needed. So what is that source? So without spending energy, the sound cannot be possible without spending energy. Okay, and how the energy gets transferred from the source to that what's called to the destination point. Okay, so how it can be transfers. Uh, so this thing we are going to see today. Okay, students. So before that, we are going to look at that some activity. First one, you have to know that. So this is called tuning fork. Okay. So it's kind of tuning fork is there. So this is called prong. This free end is called prong, and this entire is called a tuning fork. Tuning fork. And if you take that what's called rubber, with using that rubber, you just strike on that tuning fork free end of the prong. So what will happen? So it start to vibrate. So first thing you have to notice, take a tuning fork and by the free end, that means the prong. So just hit by using that rubber, any hard thing, whatever it is. So just small hit, just hit on that. So just notice that vibration and see that sound level. So what is that sound level? Okay. The next one is, see, same thing. If you take one tennis ball or whatever it is, okay, or whatever the ball, so in the fixed end, so this is the thread, and through this you have to put one hole and just tie it, and this is that ball. Now same way you have to take the tuning fork. Once you have to hit by using that rubber sheet. So take that prong, the free end of that prong, and just touch along this ball. So just make a touch on that ball. So what will happen? So the tuning fork will vibrate. So this vibration will be transferred to that ball. So you can hear some kind of sound, right? So that means what is the thing is actually, see, the vibration which can make this sound. So without the vibration, the sound will not be produced. Okay, so by that vibration, how the vibration is happen? So you have to give some energy. Some energy will be transferred to that object. That energy, without spending energy, the sound will not be there. So there will be some energy is there. That energy will be transferred, right? Okay, so, and one more thing, you have to take one beaker, okay, or tumbler, whatever tumbler, and here you have to just fill with water uh, till the brim. Brim means this end, okay, till the end. It's called brim level, BRIM, brim level. And the same way you have to take that tuning fork, and in that tuning fork, at the end of that prong, make some vibration and take this one and place it on that just with your hand, just place it on the brim level. So what will happen? The water gets some vibrated. The vibration will be transferred to that water. So some kind of wave pattern like it will be occurs here. Am I right? Same way, if you take that brim and if you look at that, take that brim and if you immerse that prong, what will happen? Take the tuning fork, same way, make a hit, small hit by using that rubber shield or whatever. Take that and immerse into that liquid. What will happen? Same way, like that vibration will be transferred here, right? So the vibration level will be transferred. So from this, what we found, so vibration which can make a sound. So vibration of the particle So vibration of the particle which can make a sound. Okay, so vibration is very important. Okay sir, what is mean by vibration? See, vibration is nothing but vibration. So it is a kind of to and fro motion, continuous of to and fro motion. So this is called vibration. Okay, so which can be happen continuously. Okay, to and fro motion which can be happen continuously. Okay students, the next thing is actually how can we hear the sound? How can we hear the sound? Or how the sound is reached to the ear? How the sound is reached to the ear? So before that, I will say one activity or one example I will say. So how can we hear that sound? Okay, so how the sound is reached to the ear? So first one you have to know students, see here one fixed end. Okay, here this is a fixed end. So in that fixed end I hang out that lot of balls. Okay, so lot of balloons, we will take lot of balloons or lot of balls, whatever. So just imagine all are in same size. Okay, now see, now I am going to take this ball. I will take this ball by using some force. I will take this ball and make a sudden push. Okay, sudden force. I am applying sudden force. Sorry. So sudden force I am applying from this ball to another ball. So what will happen? So first one, this ball will go and hit this ball, and this ball will go and hit this ball. This ball will go and hit ball. This ball will go and hit this ball and go and hit. So after hitting that, what will happen? So again it will try to come back its original position, right? Again it will try to come back. So once if you take that ball and just give certain amount of force, means it will hit and it will come back. Okay, so that means what will happen, within a fraction of second the ball gets attached or the balloon gets attached and detached, attached and detached. So this kind of, think about if it is n number of balloon is there. Okay, so if you are giving certain amount of force, what will happen, there will be some compression, some extension, some compression and some extension. Compression means when will happen, when the balloon is going into contact with that another balloon, both are compressed, stick with each other. Am I right? So that time it will be the pressurized, right, between that two particles will be very high. But when it will be relaxed, that time your pressure will be very less. Okay, so same way, just think about, this is one box. So in this box, here lot of particle is there. Okay, so lot of particle is there. Okay, okay, so now here I will blow by using any device or my mouth itself. I'm blowing. Okay, maybe this kind of any sheet or any rubber sheet, whatever, you just take this one and just give a strong blow. So what will happen, first one, this particles will be give the disturbance to the another particles, and this particle will give disturbance to this one will give disturbance, and this one will give, and this one it will give. So this kind of continuous disturbance will be occur from the source. So what will happen, continuous disturbance will be occur, but the particles, this particle will not go here. Am I right? This particle will not be go here. The particle will be same position, that same position only, but it gets displaced and it will be again come back, right? So without blowing, the ball or that particle is in equilibrium position. Okay, first one in equilibrium position. Okay, so without giving that strong blow,